Hello, 8th grade science students. Welcome to today's lesson about different types of energy and energy transformations. Take a moment and think, how would you define energy? What is energy? You could think of energy as the ability to create change or make something happen. Energy fits nicely into one of two different groups, either potential energy or kinetic energy. These different categories of energy, potential and kinetic, can have many different forms and they can cause many different things to happen. Our unit of measurement for energy is the joule. This is how we measure the amount of energy. Potential energy is exactly what it sounds like. It's energy that is stored. It has the ability to do some sort of work or cause some sort of change. It's usually dependent on things like position. Where is this item at? And in this example, in the picture, you can see that this marble at the top of the hill has potential energy. It can change very easily. Its energy can move, can change. It's got lots of energy stored up here at the top of this hill, and that can be released as it rolls down the hill. On the opposite end, kinetic energy is energy of moving items. The amount of energy in movement or kinetic energy depends on the mass of the object and its speed. Something that's much more massive, has much more matter in it, is going to have more energy. Just like if a bigger item collides with something, it's going to have a much larger effect because it had more energy. Speed is another thing that can affect the amount of kinetic energy in a moving object. The faster that something is moving, the more energy it has. In this example of the individual on the hill, they are putting in kinetic energy as they're pedaling the bike up the hill. All of that kinetic energy is stored now as potential energy. And that person waiting at the top of the hill doesn't have much kinetic energy because they're not moving, but they've got lots of potential energy because it's stored in their position. It took a bunch of energy to get that person up there to the top of the hill. And now, on the way down, that energy is released. This individual here riding the downhill section of the hill doesn't have to put in much effort. They're not pedaling, they're not putting in much energy to move the bike down the hill. It's all that energy that was started out and put in to get to the top of the hill and then is released again. Energy can change between potential and kinetic. Here's a fun example of some different changes in energy types. Watch as the Coyote and Roadrunner show you different types of potential and kinetic energy and the two of them changing between each other. As we mentioned, there's lots of different types or forms of energy. They include things like mechanical, sound, electromagnetic, electrical, chemical, thermal, and nuclear. And all of these, except for one, fit nicely and cleanly into either potential or kinetic energy. The first one, mechanical energy, kind of straddles both of them. It can fit in both of those categories because mechanical energy is energy of a moving object, and so it's got kinetic energy, but it's also dealing with its position, and so it could have some potential energy as well. This example of a roller coaster in motion shows you that the roller coaster is moving and has some kinetic energy, but it also has some energy of position. There's still some stored energy in the potential of it as it's higher up there on the loop. It has more of that energy to move down the roller coaster track. Mechanical energy you can think of as energy of moving items. Sound is a form of kinetic energy. It's caused by vibrating particles. Sounds travel through a medium. Sounds cause the particles or molecules in the air to vibrate. If you look at the example of the guitar, when someone strums the strings, those strings vibrate. The vibration from the strings vibrates the air inside of the guitar, and that air and sound waves bounce around and amplify the sound of those vibrating guitar strings. Electromagnetic energy covers a couple of different types of energy that you might be familiar with. This energy moves through the space in the form of electromagnetic waves. It includes things like light, X-rays, and microwaves. We'll learn more about waves next semester in a unit dedicated specifically to waves and their movements and effects. It'll cover things like sound, light, X-rays, and microwaves in more detail than we are here. Electrical energy, this is what most of you thought of in your warm-up. Most people, when they think of energy, think of electrical energy. It is an energy that results from moving charged particles. Electrons can flow, and as they move from one location to another, they create electrical energy. Chemical energy, on the other hand, is potential energy. It's not kinetic. And that chemical energy has been stored to be used later. Some examples might include batteries have stored electrical energy. One section of the battery has a stored positive charge. Another section has a stored negative charge, and that negative charge will flow through the device that's powered by the batteries. Matches are another good example of chemical energy. There's a very highly reactive substance that's full of energy on the end of the matchstick. As that match burns, just a slight bit of energy gets put into the match to create ignition, and it burns and releases much more energy. The food that you eat also has stored chemical energy. It has the potential to do work for you. As you eat your food, your body breaks it down, releases the stored energy in things like glucose, and creates ATP that your body can use. Thermal energy is energy of motion. It's another example of kinetic energy, and it's referring to how fast the particles in a substance are moving. A hot substance has faster moving molecules. If you think back to your work with water, the more heat you apply to water, the hotter water gets, the faster the water molecules move. Eventually, they would have enough energy to change from a liquid to a gas and fly away. Nuclear energy is another form of energy, and it happens as atoms fall apart. They send out pieces of energy, and that energy can help to power things like nuclear power. Our sun is actually one giant nuclear reaction that's occurring. Energy can change form. Energy has the ability to be transformed from one form to another. That Light energy coming from our sun can be turned into chemical energy as a plant grows. Electrical energy from an outlet can be turned into thermal energy on a stovetop. Chemical energy in food, like ice cream, can be turned into mechanical energy as someone pedals a bike. Chemical energy in the form of gasoline can be turned into mechanical energy in a car's movement. We'll take a more in-depth look at energy transformations in our activity later today. One thing to remember though, just like matter and just like mass, energy cannot be created or destroyed. It only changes form. There is a law of conservation of energy that essentially says the same thing as the law of conservation of mass, but instead of talking about mass not being created or destroyed and changing form, it's that energy cannot be created or destroyed. It only changes form. Thank you for your attention today. Have a wonderful rest of your class period.